whom doesn't know me, I just shortly present who I am and where I'm working. So we are, you will see, we are living and working there. So it's that's the map, geographical map of Italy. So it's just 50 minutes from Venice, and then 1 hour from Garda Lake, and 20 minutes from the Dolomites area. So we are in the north of the Po Valley, I would say. That's what I present normally. This is a climatic map of Italy, which is a different vision of our area. So this is the alpine climate, and this is the dry Mediterranean climate. So that's you go from this pale blue is the we call subcontinental climate, which is the transition zone normally. For who is familiar with USDA definitions, this is the transition zone between the continental, mild continental, and the sub-Mediterranean climate. The characteristic of our area is to have, you see who we are here. This is our, those are our facilities. So the offices we call a rain-out system for growing plants without the rain, because we have a lot of rain in our area, something like 1,000 millimeters per year. But some years 1,700, some year 800. So it's quite difficult to to work with a constant water supply. So therefore, we use more and more those type of setup, open tunnels where we can fully control the water, and then climatic it's looks similar to the other areas. So those are our subjects. So you see the station here. So there are three hectares with facilities, tunnels, several trials. Those were Haifa trials for 4 years with different irrigation systems to cross plants' water demand and nutrition, and see how was working with different nutrients and so on. We will see later. So just to give a picture of who we are, where we are, those are our subjects. So we started in the R&D almost more than 20 years ago. So you see all the subjects we are daily facing. This is that's why I said 12 years, because in 2002 we started working with Haifa Chemicals in the CRF business and development. First with turf, then nursery, and then agri, and then all the activities are still going on. And I like to show the person, because behind even a small company there are faces, persons. So this is Landlab team, and we like to hike together in the Dolomites to join, nature, to discuss and to have fun together. So a small team with some external technical and scientific partners, universities in different subjects: biology, biotechnology, genetics, and microbiology, chemistry, and also private laboratories. So, what's the subject of today? What is a turf? What is a lawn? Differently from many other, or for almost all the other crops, agriculture is normally growing. Turf grass is a plants community. So it's not one species, one varieties. Now genetics is going to the F1 or clones even. And here we work with plants community, which means that we have to deal constantly with several species, and within the species several varieties. So it's not as a canopy, as a system is stable, but internally you can have fluctuations in the population, as is normally happening in every population of plants, or not only plants but also mammals or fishes or whatever. So the general behavior, the general status is constant, or should be, but internally can be a lot of changes. So this is the first difference from turf grass surfaces versus agricultural normal crop. And the second is that the grass are perennial. So we work with plants. Some of them are the same plant can be there for 15, 20 years. So it's like a shrub, like a tree, but is only a few centimeters height. So it's a different volume, different biomass, but it's a perennial plant with a capacity to have a vegetative reproduction over time. And we'll see how grasses are maintaining the stability of the population. So those are the two key distinctions between normal crop, annual or months long, and also and grass, and also versus orchards. Orchards are perennial, but orchards are in our area mainly falling leaves, living leaves. They have yearly big variations. Grass, some species can be very flat in vegetation, depending on the temperature and other conditions, which is another big difference between those plants and many others. Turf grass is cultivated for specific functions. It's not give you food. It's cultivated for protecting the soil. Not here, but in many orchards and vineyard, grass is grown for protecting against the erosion. Grapes in many areas in the north where rainfall is sufficient are used a lot for stabilization of the soil, for the reduction of some diseases, and also for the reduction of the production. You have good wine if you have less production, and grass can control the plant expression by competing for nutrients and water, of course. So they are used for sport. I know many of you like very much soccer, football, rugby, whatever. Grass is the plant used for all the outdoor sports. If you think to any type of outdoor sports, from horses to humans or whatever, that's grass. And leisure, amenity for laying, for taking sun baths, for playing, jogging, or whatever. So these functions are specifically done by a wide number of grass species and varieties. I use some tools. I like to. This is a web page you will get, and then you can play with. I show some just to have a fast overview on what is grass. This is UC Davis, so it's on the web. So this is a perennial plant. I would like to start by showing what we do normally here. So this is the heart of the grass. So those tissues are located between the soil and the air. So in this very thin position, we find the plant structure. It's like a wheat, nothing different. It's a grass, is a wheat type. Genetically, Lolium perennial ryegrass is 98.5% similar, the same of rice. So the genome of Lolium perennial is almost rice type. So there are not wide difference. So this is a typical grass morphology with all the meristematic tissues on the end of on the upper level of the soil. No, this is not what I want. This one. This is nice, so it's funny. What's happening here? we mow regularly, every day, every 2 days, and you see how is grass growing. Grass can grow from 2 levels, from this intercalary meristematic tissue, which is located at certain level of the above the soil, depending on the grass types, structure, density, light penetration, and so on. It can grow from this level here. Yeah. So this is the intercalary meristematic tissue, and this is the bud, the heart, the crown. That gives immediately interesting conclusions where we move grass. If we move very too deep, we go below the intercalary meristematic tissue, the plant has to grow from the bottom. It takes time, it takes a lot of energy. So that's why every greenkeeper has in mind to keep a very constant growing height, mowing height, not to go below this intercalary tissue system. Otherwise, plants has every time to start from the bottom. Grass is a plant with flowers. We never see the flowers because we mow very often, producing seed and producing flowers, of course. Flowers are also coming from the apical meristematic tissue, going up. So it's, if you think at wheat, barley, whatever, that's very similar. The huge difference is that if you move wheat 3 times, the plant is dead. A grass you can move every day. Some species you can move every day, or twice a day even. The plant is always regrowing. The other interesting is here. What about the morphology? So we have a different type of grasses. We have grasses that are tillering here, so making like wheat, like bunching. So many species are like this. The tillers, so this part of the mother plants can die, but the tillers can survive. Tiller can produce another tiller, and a grass can, one plant, even if tillering slowly, can populate a wide area. That's typical for some species like tall fescue, ryegrass, some red fescue types, and so on. A different growth system is here. Grass can grow via stolons, which are above the soil level, running above the soil level, and also via rhizomes, which are perennial, woody tissues at different depth in the soil. Some plants have only stolons, Agrostis stolonifera. Some plants have only rhizomes, or Kentucky bluegrass. Some others have both. You use a lot in Israel here warm season grasses, and warm season grasses have both types of tissues. 3: flowers, stolons, and rhizomes. Those are the insurances for the plants. So heavy frost doesn't matter for Bermuda grass. The upper plant will die, leaves and stolons, but the rhizomes can regrow in the season. So you find actually those type of plants in many areas. I show here. We split normally, which is not a botanical division, but is a morphological and growth partition turf grasses in 2 main groups. One is called cool season grasses, and the other is called warm season grasses. You see here all the details, and you see here the typical growth pattern, but I will get deeper later, of cool season grasses. So it's a bimodal system. It looks like if you look to the roots growth and the upper part growth, they are not happening in the same moment. And even here. So you have first a growth when the soil temperature is growing slowly. Later you have the upper soil part growth with the flowering, of course. And then summertime, that's typical in the continental and subcontinental area, the growth slow down dramatically. You may have, with high temperature, you see here the limits, almost no growth. When the temperature is going above 30, 35 degrees, the cool season grasses do not grow at all. Neither roots nor leaves. No way. You can push with nitrogen, but if you push with nitrogen, you are using the reservoir, the carbohydrate. Therefore, you are depleting the green up later. Because it's the limit is not the water, the limit is not the nutrition, the limit is the temperature. Of course, between the different species, you may have variations in the temperature limits. Some red fescues from native on the northern part of Europe are limited at the low temperature, 24, 25 degrees. Other species growing in the transition zone are limited at 30 degrees. But between this range, almost all cool season grasses do not grow too much. The other difference between the warm and the cool season grasses is that the cool season grasses do not have any induction by low temperature. Bermuda or low light even. Those are the two drivers, light and temperature. Bermuda grass or the warm season are driven by temperature and light. If there is low temperature, there is an induction to dormancy. And before the plants can grow up again, the plants need a sum of temperature above 15, 18 degrees. This is not happening for the cool season grasses. If we have a week of frost, minus 10, 0, and the week after is plus, the cool season grasses start growing again. If frost is coming, stop growing. So those plants are not inducted by low temperature to get rest, to get into dormancy. Can be inducted to get into dormancy from the drought. That's another dimension, another situation. But low temperature and high temperature, no. So every time there is the right temperature range, the cool season grasses can grow. This is the growth pattern, you see, unimodal of the warm season grasses. So leaves, flower, and roots are growing together at the same time. Those plants have a much higher light demand as a first. Those are C4 plants as a photosynthetic pathway, not C3. So cone type. The growth can happen up to 40 degrees even, but the limit is in the low temperature. Below 15 degrees, there is no any growth, active growth anymore. Below 5 degrees, the plants start losing the chlorophyll, and below 1 degree, the plants leave completely the leaves and get dormant. It is enough 2 nights at 0 degrees, and the warm season grasses stop completely growing and cannot recover if the temperature is rising again. So, hope these pictures give you a rough idea on what we are talking about. This wide population of plants. Move it. Yeah. So what we are looking when we use grass? We need the persistency of the system. That's the goal. Every greenkeeper, every turf grass grower would like to have a stable plants community. So going to the what we call the subclimax, which is not a climax because we are interfering with the community. Climax is a natural situation, a balanced natural situation according with soil and climate conditions, but it is a subclimax because we are interfering, driving with water, mowing, playing, and nutrition. But what we would like to have is a balanced composition over time. Why? Because if the species composition is changing, then we not deal anymore with the initial community we were working for, but we deal later with another botanical composition, another population that may have completely different attitude, for instance, to the wear, to the use. If we combine two species, one is weak in the wear tolerance and the other is strong, if the weak species will take over the strong species, over time we get back in the wear resistance, and then we have troubles. So there are some factors that are playing in the stability of the population, which is the initial composition, so what we are using when we start sowing. The water management, the nitrogen management, quantity, type, and partition, not only quantity. The reaction to the stresses of species and varieties, and how often we move, how deep we move. You know, if you have a population and a greenkeeper one day decide to get down by moving from 4 centimeters to 1 centimeter because somebody tells him, oh no, it's too high, we cannot play on it, and you go suddenly done, and then you cut at 1 centimeter, you immediately make a selection. Species and varieties that can regrow for 1 centimeter will take over the other species and varieties, and your population changes completely in one shot. And of course, intensity and type of use is another factor of interfering with the composition of the population. What is the ability of those plants is that we can have very wide, the same population through a country. And on the other hand, we can have in one location different plants, different species. I try to explain. I don't know if it's here. No. Anyhow, so if we take one species like tall fescue, which is a typical, its Latin name is Festuca arundinacea, it's typical of the transition zone. First, keep in mind that all the cool season grasses are native on the European and Middle East area. There is no one species native in the North and the South America on the cool season grasses worldwide used for turf grass purposes. So when somebody is listening, this is an American, I say, no, this is a European plant transported to US, maybe bred and crossed or whatever, selected, and then reproduced. But the native area of those plants is Europe and Middle East, some Middle East zone. So in this native area, you can find wide genetic background. Therefore, breeders are traveling around collecting plants, still collecting plants in different areas where it's very dry and hot and cold, and then breeding with plants growing in another area to make new populations. So that's why you can find tall fescue in the north of Germany and in Israel as well, so which is quite climatic big distance. But if you go in a garden in the north of France or in the north of Italy, you can find in the same location plants from the South European area and from the North European area. It shows the adaptation of grasses to different climatic conditions. It's a wide adaptation system. Of course, as far you go from the native area with the plants, as less resilience, resistance, and adaptation you get. So if you grow Agrostis stolonifera as they do in the golf courses in the Scotland, that's okay. But when you grow in Turkey or in the Mediterranean coast, you can do it. But then you are plenty of troubles with irrigation, with diseases, with growth, and so on. So the maintenance intensity is dramatically growing when you move a plant far away from his native location. So just for giving an overview, this is the new botanical definition of those plants. Wheat is also inside here, this family. We studied Graminaceae, but now are Poaceae. Just an example of what is listed in official lists through Europe, in EU countries, per species. So you can find a wide number of varieties, like you have in tomatoes. It's the same. Or you have in wheat, or you have whatever you use it. Also here, there is a heavy breeding activity going ahead on a daily basis, different players, and breeding, selecting, and applying and registering varieties in different areas. Now Europe has one registration system for all the plants. Zucchini, tomato, eggplants, and grass, potato is in one, the GNIS. If you type GNIS, you go into the European list, plant variety list. It's, the heart is in Angers, in France. And then you find all the plants, all the species, and also the turf grass one. So you see how many varieties you have. This is not updated, by the way, so these numbers are growing. But some varieties are getting in, and some other are getting out. And you will see why. So those are the cool season grasses. And those are the warm season grasses growing in the main area of breeding and selection of those plants is in the United States. Because the climate in the United States is split in three big strips: the cool on the north, the transition zone, and the warm on the south. So the population is also split in three zones. So that's why they do need species and varieties for all the climatic areas. So you have a wide number of Bermuda. This is Bermuda grass. This is coming from Japan area, native. That's why Japonica. And you see here some of those plants, but you see only here, can be reproduced by seeds or by stolons. So you can have a vegetative reproduction or reproductive reproduction. Where in cool season, you have only one way, which is the seed. No one of these species can be reproduced by vegetative parts. But here, yes. So some of them are clones, with all the advantages and the risks of the clones. The advantages are clear: homogeneity, stability, well-known performances. The risk is also well-known: disease aggression, critical conditions. All the plants are genetically the same. Therefore, if you have 1 million of plants in one area, that's gone. You keep in mind that in 1 square centimeter, normally you can count up to 5 tillers of grass in 1 square centimeter. So it's about 50,000 tillers per square meter. So the density is very high. The contact between the plants is also very high. So that's why disease is a very critical factor for those plants. I would like to show you about varieties, what the German situation, but it's just to give you an idea of what we are talking about. You see again the uses: lawn, sports, golf, landscape. So different uses. And the surfaces are quite large around the world. And as cities are growing, turfgrass is also growing. 50% of the budget of European municipalities is from the green areas is allocated for the turfgrass maintenance, 50%, 50, which is a large in large cities is a large quantity. They can have up to 40, 60 hectares to move every week, to fertilize, to irrigate, to clean, and so on. Yeah. So I show you how they run the control of the varieties. So you see it's German, but France is the same, Italy is the same, and Denmark, whatever. So they check one variety in different locations to see the adaptation of the variety. So not only one location, but different areas as a first. And then you see the plots, a typical turfgrass. If you look to from Google to our station, you see also a lot of plots. So different species, colors and density and so on. But what I like to show, the machineries. This is a machine they use for simulating the soccer. Yeah? So it's a wearing machine to check the variety at different intensity of destructive play game. This is a guy checking and scoring. This is the number of listed variety in the last 30 years. You see, from 40 to 150 for 3 species. And what I like to show is that this chart. This is when the breeding activity started to be significant all over Europe, and this is 3 years ago, 2009. And you see the green part, which are varieties scored with a number between 7 and 9, so high scoring, high quality. You see the bars growing from 35% up to 70%. Almost now, 70% of the varieties listed in Europe are very high performing for different reasons: persistency, stability, resistance to disease, and resistance to the wear. This is long, and this is sport. You see, until 92, few varieties were very well resistant to the heavy use. And now almost 60% of the varieties are strong resistant to the heavy use. That's why when you watch TV, you watch, I don't, but when you watch soccer, you see better fields compared to 20 years ago. Everything has to do irrigation and nutrition, of course, but genetically it was dramatically improved in the resistance to the wear, to the play, to the game. Now they are looking for the shadow. This is a big issue. This is another species, also visual merit. Also, you see, up to 55%. This is a very important species. From until a few years ago, varieties were not adapted. And now almost 30% are adapted to the heavy sport. And if you look here, the total number of varieties, then you see in the last 20 years, 16 almost, the progress in genetic. It takes 12 to 15 years to breed a new variety. So when you start breeding and thinking that, okay, the goal is drought resistant, then it takes 10 to 15 years to arrive to the final product. So it's a long process because you cannot have F1 here. It's a pollinated cross population. So you work with different genotypes. So it's a population, it's not one line. That's Lolium perenne. You see now up to 70% of the varieties are resistant to the wear. means you can have really very hard wear activity on top in terms of hours per day, depending on the variety you use, which is the other key factor. This is the total, the average, but you may have variety with very high scoring still, and you see variety with low scoring. So it depends on your choice if you focus on this top or on the bottom, and the results can be dramatically different. Yeah. So those are the goals. So you see the activity in the last 25 years. So now 70% of the listed variety achieve best scores for suitability for loans and sport. Big success with this species. We may say that there is more variation within a species than between the species genetically. So still we can dig deeply into the genetic ground of the species and find ecotypes and then cross and reproduce for specific purposes. And those are the main goals nowadays in the turfgrass world: drought resistance and disease tolerance. Drought is important because water costs, and put irrigation everywhere in a city, it's very costly. Not only the irrigation system, but also the control, and the main troubles are down by the irrigation management. We will see later on. So a goal of many greenkeepers is to have varieties, species varieties that can resist at wide climatic fluctuations, because the matter is not the total water, it's the concentration of the water events, which is a critical factor, by compacting soil and runoff or whatever, and then drought. And the disease tolerance. You know that in 3 years from now, at European level, the PVP, the plant protection product, insecticide and fungicide, will be banned in the city areas. So cannot be used anymore. No one. Nowadays, only few are listed for use in turf and in amenities, but in 3 years, no one can be used. Therefore, every city, every one has to deal with diseases and weeds in completely other ways we were used in the last 30 years, which is a big challenge nowadays. So, but also interesting, opening doors, I would say gates to different management systems, nutrition systems, microbial uses, other tools that can be helpful for this purpose.